Your FastMCP server is running, but how do you actually test that GitHub OAuth Authentication works before deploying? You'll see exactly how to build a client that automatically handles the OAuth flow, opening the browser for login, storing tokens securely, and making authenticated calls to protected tools. The pattern even caches credentials, so you won't need to re-authenticate every time. From FastMCP Import Client. Import Asyncio. Async def main. Hash the client will automatically handle GitHub OAuth. Async with client. http://localhost 8000/mcp auth equals OAuth as client. Hash first time connection will open GitHub login in your browser. Print authenticated with GitHub. Hash test the protected tool. Result equals await client, call tool, get user info. Print f GitHub user, result GitHub user. If name equals main. Asyncio, run main. This demonstrates the OAuth proxy pattern for integrating traditional OAuth providers with modern RPC frameworks. The pattern bridges systems that don't natively support dynamic client registration, like GitHub's OAuth, with frameworks that expect standardized authentication flows. What makes this distinctive is how it handles the authentication handshake transparently while maintaining the framework's native security model. The approach works by externalizing the OAuth flow into a dedicated provider component that manages the entire authentication lifecycle. The client initiates the flow through a simple auth parameter, while the provider handles browser redirects, token exchange, and claim validation behind the scenes. This separation of concerns lets developers focus on business logic, while the framework manages the complex OAuth dance, including token refresh and scope validation. This pattern matters because it solves the common problem of integrating legacy authentication systems with modern architectures without compromising security. It's particularly valuable when you need to secure RPC endpoints with existing identity providers, but want to avoid writing custom auth middleware. The trade-off is slightly more complex initial setup, but the result is a clean, maintainable integration that works across different transport protocols. Let's break it down line by line. From FastMCP Import Client. Imports the client class from FastMCP, the core interface for connecting to MCP servers. This handles all low-level communication, authentication, and request serialization. Import Asyncio. Imports Asyncio, Python's built-in library for writing concurrent code using async await syntax. This enables the async operations required for FastMCP's non-blocking client-server communication, allowing the program to efficiently wait for network responses without freezing. Async def main defines an async entry point for the script. This is required because FastMCP's client uses async I/O for network operations, and Asyncio needs a coroutine to run. The pattern ensures non-blocking execution while maintaining clean resource handling. Hash the client will automatically handle GitHub OAuth. Async with client, http://localhost 8000/mcp auth equals OAuth as client. This establishes an authenticated connection using FastMCP's client context manager. The auth equals OAuth parameter triggers automatic GitHub OAuth flow, handling browser-based login and token management. Context manager pattern ensures proper connection cleanup when the block exits. Hash first time connection will open GitHub login in your browser. Print authenticated with GitHub. This confirmation message signals successful OAuth completion. The browser-based GitHub login flow has authenticated the user, establishing a secure session for subsequent API calls. This pattern is common in CLI tools that require user-specific permissions.
Hash test the protected tool. Result equals await client. Call tool. Get user info.
This invokes the protected getUserInfo tool through the authenticated client. The await handles the async RPC call to the FastMCP server, returning structured data about the GitHub user. This demonstrates how authenticated tools work. The server validates credentials before executing the request.
Print F GitHub user. Result GitHub user.
This prints the GitHub username from the tool response, demonstrating successful authentication and API integration. The F string extracts the GitHub user field from the JSON result, proving the OAuth flow and tool call both worked. This is the verification step that confirms end-to-end functionality.
If name equals main.
This is Python's standard entry point guard. It ensures the async event loop only runs when this script executes directly, preventing accidental execution if the module is imported elsewhere. Critical for reusable modules that also contain executable code.
Asyncio, run main.
This boots the async event loop and executes the main coroutine. Without this, the async code would never run, as Python doesn't auto-start the event loop for top-level async functions. Standard pattern for async entry points. Async OAuth client pattern. This client demonstrates FastMCP's browser-based OAuth flow, where authentication happens transparently through a temporary local server, while your main application continues running. The token cache silently handles refreshes until expiration, making subsequent runs appear instant to the user. Your production configuration will need encrypted storage for these tokens, as shown in the Redis /fernet example.
The client that never asks for permission already has it.